Not me. I'm more of a cautionary tale. It's more like, don't turn out like me, guys. Nikita, just, you don't want to end up like me.
Now you kidding me? My father's a cautionary tale for me.
Oh, Nikita.
What? Yeah.
Okay. Inverse. Trig. Functions. That's the one of the big words here. I'll discuss why that word is so important in this context in a second. Number 17. We're going to ask some questions like, what is the inverse sine of 1? Okay. So at the end of this, we're going to have in this box a math fact. It's not one that you just have memorized really, but it's one that is fundamental enough that hopefully you don't have to do a whole big process to figure it out. So anyway, for these 12 questions, I want you to visualize the mental process. So this is asking a question. It's asking the sine of what would equal 1/2. What angle out there has a sine value of 1/2?
30.
Yeah, if you're working in degrees, the answer is 30. Okay. If you're working in radians, what's 30 degrees in radians? Now, let's suppose you were new to this stuff. You would say that you might not jump straight to this. You might go to your notes or whatever and say, well, I know that there's two special right triangles that we're dealing with a lot here. There's this one. There's the 30, 60, 90. And there's the 45, 45, 90. And so when you ask the question, which of those angles has a sine value of 1/2, I hope you look at this right away and say, well, clearly you're not going to get a sine of 1/2 out of this guy, but this guy is going to have what you're looking for. And then you say, well, can I fit that triangle onto the unit circle in a way so that the y value is 1/2? Is that possible to do? Yes. It just so happens that the way I drew it on the board is the exact orientation, but we might have asked, what's the inverse sine of √3/2, and that triangle would have been flipped, right? A little bit. So, and that angle there, like you guys said, that's got to be a 30-degree angle, and we know that 30 degrees is equivalent to pi/6 radians. In fact, if you take a calculator and you put it on degree mode, and you type in inverse sine of 0.5, guess what's going to come out?
30 degrees.
30. Yeah. If you had been on radian mode, you would have gotten pi/6, but as a decimal. 1 point something something. Do you feel okay?
Mm-hmm.
Now, is anyone going to hit us with Mr. Actually? Well, I asked a question earlier, which was, what angle has a sine of 1/2? And Mr. Actually would say, actually, there's an infinite amount of angles that have a sine of 1/2. Is Mr. Actually correct?
Yeah.
He is correct, yes. So you have to address that. Because he would say, well, wait a second, you asked me this question. I could name you 1,000 numbers that can go in there. For example, I could say pi/6. Who can tell me another angle that would have a sine value of 1/2?
2 pi/12.
2 pi/12. Oh, it's the same number.
Exactly.
No, it's a different number though.
That takes more effort.
5/6.
5/6. You understand what I'm talking about?
Mm-hmm.
So pi/6 has a sine of 1/2. 5 pi/6 has a sine of 1/2. Well, okay. Well, couldn't I have gone the other way and landed here by going -7 pi/6?
Mm-hmm.
Is this making sense? Yeah. Or could I maybe have gone just all the way around the circle and then additional pi over 6. So could I have gone 13 pi over 6? So I can just keep going forever, right? So the idea, this is correct, by the way, this answer is correct. So the trick is, it's just like we did with our inverse functions. You know, sometimes we had to restrict the domain to make them invertible.
Mhm.
So what you do is you restrict yourself to, in the case of sine, this part of the circle, the right half. Okay, so think about that. Why pick the right half of the circle? Why not the top of the circle? Or why not the bottom of the circle or the left side of the circle? What? Not quite. Well, think about the sine values you get on this part of the circle. What's the sine up here? 1. What's the sine down here? And what's the sine here?
0.
So do you see how we've hit the full possible range of sine values without hitting the same one twice?
Mhm.
So therefore, what that means is the angle that this outputs, i.e. the range of this function, the range of the inverse sine function, has to be angles from negative pi over 2 to pi over 2. This is the range of the inverse sine function. Does that make sense?
Mhm.
So is it possible then for this to spit out the number 5 pi over 6? No, it's not, because 5 pi over 6 is not in that range. So it's a little bit of a cheat, right? You're like, because if you look at the sine function, here, I'll just, if you graph y equals sine of x, this is something we're going to do later in this class, but the graph looks like this, and it goes forever. That's not going to pass the horizontal line test. So what you do is you just grab this part of it. You say, that part does pass the horizontal line test, so I can invert that part.
Mhm.
All right. Want to do one or two? What's wrong?
It looks like physics.
What does? Oh, this?
Yeah, isn't it cool?
This stuff, if you think about it, why does trig come up so much in so many things? Well, as you move along this circle, paper, put that away. As you move around this circle, you are, your sine and your cosine and your tangent values are hitting all these values. Well, how many things in the world do this?
A lot.
A lot.
Mhm.
And how many things, it might not be a circle, but how many things do something that repeats over and over again? A lot. Tons of things work periodically, cyclically. Anything that behaves cyclically or periodically can be related somehow to this, to a circle and something. Let's do a couple more examples. What is it? Inverse cosine of 1/2. Inverse cosine of 1/2. So we're asking the question, what angle out there has a cosine of 1/2? So it'd be right here. So you can there's multiple ways you could rephrase this question. One way is, how can I put a location on the circle so that the x value of my point is 1/2? That hopefully gets your attention over there looking at the 30, 60, 90. Tells you that this angle here is 60 degrees, also known as pi over 3. We like this one right now, this time in our lives. And so the answer to the question is pi over 3. All right, I got a tricky question for you. What part of the circle do you have to limit yourself to in order for this inverse function to be an invertible function?
Top.
Right.
So some people are saying top, some people are saying right.
Yeah, it's the
Top,
top.
top right, bottom left.
Let's look at the right. Let's suppose we were going to say, oh, maybe it's the same as the sine. Well, there's a problem because on the right half of the circle, like this point down here, negative pi over 3 has the same cosine value, right? They both have a positive 1/2 cosine value. Does that make sense?
Yeah.
So I want to make sure that I'm on a part of the circle that hits all the possible cosine values. So this, what's the cosine here? 1. What's the cosine here?
Zero.
What's the cosine here? So therefore, for the inverse cosine, you actually are restricting yourself to the top of the unit circle. So can this function ever spit out a negative number? Can the output ever be negative?
No.
Nope. So my range, the range of the inverse cosine is what? What to what? That's the range of the cosine function. So remember, this is going to spit out angles. So what angle is this? 0, right? So the numbers I wrote here, those were the cosine
Oh,
values.
right, okay.
This number, the cosine of 0 is 1. The cosine of pi over 2 is 0. And the cosine of pi is negative 1. So the angle measures that can come out of this would be anything from 0 over to pi.
Okay.
Make sense?
That.
Okay. Last one I want to look at for now. And by the way, just to clarify something, the range of the sine function is the same as the range of the cosecant, because cosecant is the reciprocal. The range of the inverse cosine is the same as the range of the inverse secant, because those are reciprocals. So when you get to those, you handle them in the exact same way. But tangent's a little bit weird. Look at C. So there's 2 questions to answer. One is, what do you guys think, what angle has a tangent value of 1? So saying inverse tangent of 1. 45 degrees, right? We love radians though. So yeah, remember, how do you get your tangent? Tangent is related to, I heard someone say y over x or x over y or something. So just like sine comes from the y value and the cosine comes from the x value, well, the tangent is the y over the x. So if my tangent is 1, I need an angle that has the same y value as x value, right? So that's got to be the 45-degree angle, or pi over 4 radians. So the answer is pi over 4. What part of the circle do we look at for this?
You have to be anywhere.
Well, you don't get a different time.
Sort of. I mean, you could make it work by doing, say, the left side of the circle. You actually could make, but the way they do it, capital T they, is they pick the right half of the circle. So now why is that? Well, here you hit a tangent of 0. Here you have all the possible positive tangent values, and down here you have all the positive negative tangent values. So you've covered every possible value of tangent. So the range of the inverse tangent function is the same as the inverse sine function. So it's everything from negative pi over 2 to pi over 2. Okay? Make sense? This one can be a little, it's important to know this because, let me give you, that's probably on there somewhere, I'm not sure, but if you're answering this question, what's the inverse tangent of -1? What's a tempting but wrong answer to that?
Pi over 4.
Pi.
Well, for my the tangent of pi is 0.
3 pi over 4.
3 pi over 4, very good. Right here, because is it true? Is the tangent of 3 pi over 4 equal to -1? Yeah, that is a true statement. That is very true. However, 3 pi over 4 is not in this restricted range that we created artificially. So the actual answer to this is
Negative
-pi over 4. Because we have to be between these two numbers, right? This location in the circle is also 7 pi over 4, right? Could I go 1, 2, 3, 4, 5, 6, 7 quarters of pi? Again, it's true that the tangent of 7 pi over 4 is -1. That's true. However, the inverse tangent of -1 is only this one single number. You see why that is kind of confusing? It's my last remark here is it's very similar to this. If I say x squared equals 9, how many answers are that to that question? There's 2 answers, right? There's 3 and -3. However, if I say, what's the square root of 9? That only has one answer, +3. That's kind of what's going on here. To ask the tangent of what makes -1 technically has an infinite number of answers. But to ask what's the inverse tangent of -1 only has one answer. Okay? Are you,
Really puzzled.
you got a question?
No.
What's the confusion?
It's just, this guy's taking it in.
Okay.
Can you do another example?
Yeah.
Like,
Yeah, sure. Which one, please?
um,
Want to see the next problem?
yeah, just be.
Yeah. I'll do you one better. I'll give you 2 more simple examples. I'll give you one just off the top of my head, just a simple one, which is suppose you wanted to know what's the inverse sine. I'm going to pick a negative number of -√3/2. Okay, let's answer that question. What location on the unit circle would give us first of all, a negative sign value? So where do I live?
Down in the bottom.
Down here. And how do I make it so that the sine value, the y value is this?
Yep.
Value like that, right? Now, how do I write my answer? Remember, my range is all of these angles. Anything from -1/2 pi up to +1/2 pi. So how do I describe that angle? -pi/3. Questions on that? You sure?
Yeah, what?
Where does the triangle come?
-pi/3 come from?
The angle. It's the angle.
Isn't the angle 60 degrees?
You could say it's -60 degrees if you're working in degrees, but we're working in radians, so use the radians.
Okay, where does the triangle come from? Like, how do you know? Like, how did you just think of that?
Because there's 2 famous special right triangles. Okay. This one is this one. If you don't have these two memorized, you're creating a lot of confusion for yourself. Okay? You have to know this. Okay? So when you see this number, your mind immediately goes to like, okay, I'm going to be forming a 30, 60, 90 triangle on the circle. Okay? You also got to know this triangle. Okay? We'll do another example going forward here where suppose I told you that some angle out there has a cosine of root 2 over 2. What do you think the angle is? 45 degrees. But we're working in radians. So we're not going to say 45 degrees. We're going to say pi over 4. You understand? Okay. Now let me throw something out here. Maybe this is confusing you. Suppose I said, oh, sorry, I wrote it wrong. Inverse sine. If I said, what's the inverse sine of, I don't know, root 5 over 7? Well, what do you think about that? Do you think that's something we know the answer to?
No.
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 No, it is not. Not even close. Now, for that particular one, if I'd say, so what we're getting at here is there's a few special angles, right, out there. 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0 degrees. Those angles all have nice, simple sines and cosines and tangents, right? That's why we study them. This ratio, I mean, if you're curious, I'll tell you, take my calculator. I'm going to put it on degree mode and say, Mr. Calculator, what's the inverse sine of root 5 over 7? Taking bets.
-50.
It can't be negative, Zane, because it's positive. Okay. Well, let me put it. This is describing some angle whose opposite to hypotenuse ratio is root 5 over 7. And this is the angle I'm looking for. It turns out it's 18.62895 blah 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 forever degrees.
Yeah, I was close.
Okay. Does that make sense?
Yeah.
The vast majority of numbers that I could plug in there are going to have totally weird answers that can't be written as nice fractions of pi. Okay? So, no more questions or?
Okay.
No.
But do you see how this triangle goes from living there to living here?
Yeah.
Okay. And then do you see the way I drew it in a way so that this right here is 60 or pi over 3 radians. But notice this angle, right? That's why I'm going clockwise, so that's why it's a negative angle. Okay. The x value is 1/2. The y value is negative root 3 over 2. What's the hypotenuse? 1. It's unit circle.
Okay.
Do you guys want to go over one more example?
Yeah.
Okay. All right. The inverse cosecant of -2. Do we know, is this equivalent to a different inverse trig function?
Sine over 1.
Yeah, it's the inverse sine of -1/2. So here, I might go like, suppose I'm having a little bit of trouble getting situated. I'd say, well, what is it saying? This is saying that the cosecant of some angle is -2. And that's equivalent to saying that the sine of some angle is negative 1/2, the reciprocal, right? Do we all feel okay going from here to here and then from here to here?
Mm-hmm.
Okay, so then what I do is I say, is this one that I know? First of all, it's possible the person writing the problem messed up. If this was like a 1/3, you'd be like, excuse me, what is this? You want me to use a computer to like estimate this? Or only certain numbers are going to connect us back to these two famous triangles. Okay, so in this case, yeah, I can get a sine value of 1/2. How do I make this triangle live on this circle so that the y value is negative 1/2? Yep, I gotta go like that. Something to keep in mind on these triangles. One of the legs will always be on the x-axis, and the other leg will be perpendicular to the x-axis. Unless, of course, you ended up here, 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 or here, and there's no triangle you even have to worry about, right? Okay. So I probably should have given you a really simple one like this. My bad. What's the inverse sine of 1? What angle produces a sine value of 1? Pi over 2. Pi over 2. I knew what you meant.
Yeah.
This is a good place to assess your own understanding. How do you feel about a statement like this? It could be anywhere from profoundly obvious, like that to me is like 1 + 1 = 2. Yes, that's abundantly obvious to me. Or all the way down to, I don't even know what that symbol is. Like, I don't know what I'm looking at. I don't know, what is that supposed to say? Is that even a math statement? So obviously you guys aren't going to be at that. That would be like a little kid would have no idea what he's even looking at there, right? So you got to gauge yourself. Where are you sitting? What happens to a lot of students is they're at a place where they're like, well, I get it now that you've shown it. I get that on the top of the circle, right? The top of the circle, the sine of pi over 2 is 1. I understand that, but I had trouble getting there myself. You guys feel like that?
Wait, sine is 1 or inverse sine is 1?
I'm saying the sine of pi over 2 is 1.
Mm-hmm.
That's a true fact. Also, the inverse sine of 1 is pi over 2. Those are inverse statements.
Oh, no, I get it. Yeah, now I get it.
We didn't. Okay, let's just finish this question. So sorry for the aside there.
No, it made me get it.
To finish this question, you have this and say, okay. Also, guys, if you're confused, it helps me if you can identify exactly where you're dropping off. Like, you gotta go, okay, I get how you turned this into this. That's inverting an invertible statement. I get how you're getting from this to this. That's just the fact that sine and cosecant are reciprocals. That's obvious, right? It's easy. But maybe I'm having trouble getting from this to this.
Yes.
Yes.
Okay, so do you see how I used to have these triangles? Do you have any scissors? Any of you guys have scissors? I used to have these triangles and then I lost them.
Scissors.
Any scissors around there?
Scissors.
Oh, lit. Let me have those scissors. Watch this. Mr. Paper, sacrifice yourself. I can make a bigger version of this with some help. I've just made Mr. 30, 60, 90. This is what's happening. Right now he's drawn like this. Sorry it's white, should I color it in to make it more visible? Here. Okay. This is a 30, 60, 90. How big is the hypotenuse? 1. How big is the short leg?
1/2
How big is the long leg?
root 3.
Good. He lives here right now. But I need him to live on this circle in a way so that his y value, right, is negative 1/2. Well, that means his short leg, the 1/2, has got to be the vertical one, right? So in my mind, I go like, bloop. So it used to be like this, but now he's like this. I don't know why I flipped it over the first time. So 1/2
We did it
root
flip.
3 over 2. But if I need that 1/2 to live on the vertical, right, axis, then I need to turn him so he lives like this.
That makes more sense.
And so, well, what happened when I did that? Well, then this angle here is the 30 degrees, right? And then I go, okay, I'm not supposed to be dealing with degrees. I'm supposed to be dealing with radians. Well, I know that 30 degrees is the same as pi over 6 radians. But then I go, wait a second. To go from my starting position of 0 and end up here, I had to go clockwise.
It's
So we have a convention of calling that a negative angle. So the answer to this question is negative pi over 6. Let's just do another example. Let's just keep going.
What about?
Let's actually jump down to h. What?
Oh, what about the cotangent thing? Is it different?
You can do cotangent if you want. Okay. F? The most respectful question. Is that a new mimes where you say respectfully?
Respect.
Is that a mimes?
Oh.
Where you say, this is bussin', respectfully.
What?
Again, beyond my comprehension. I'm
Mm.
just grasping at straws here. I can't.
You roast somebody,
Uh-huh.
and you say respectfully though.
Oh, really? Is that the meme? That's like an ancient one where you just brutally insult someone in the rudest way and then say, no offense. No offense, but let me insult your intelligence, physical appearance, your family, everything. Okay, so this one says, this one, you got a few options here. Inverse cotangent of root 3 over 3. Let me show you. I really hope this doesn't confuse you guys, but would it be okay if I showed you a semi-alternative method?
Yes. Yeah.
Suppose I was asked this question just in a vacuum, so to speak. What I would probably do is I'd say, well, you're telling me that the cotangent of some angle is root 3 over 3. And I'm glad you didn't put a negative number there because that would have added an extra layer of difficulty to it. So I can just really focus on, and what do you call it? I'm blanking on the word here, sorry. Triangle. An acute triangle. I was thinking of acute triangle, not obtuse, sorry. I was thinking of a triangle where all the angles are just under 90. 90 or under. Right triangle. So, okay, well, can I do this? Let's say this is my angle. How do I label these two sides so that his cotangent would be this number? Beautiful. You guys see what you did there? Does everyone agree with that?
Yes.
The tangent of this angle is 3 over root 3. The cotangent, the reciprocal, is root 3 over 3. Cool beans? A little bit of Pythagorean Theorem time to get the hypotenuse. Because I'm still kind of confused. What the heck am I looking at here? Well, if I went 3 3 squared plus root 3 squared equals hypotenuse squared. 9 plus 3 is 12. Right? You guys still with me?
Mhm.
Now, what if I divided it? What if I shrunk this guy? So I'm here the whole time. I'm like, is he one of these guys in disguise?
Is he?
Is he? Let's see. Let's shrink him. Shrinky dinky. What if I divided everything by root 3 to make this 2, make this 1, and make this root 3?
Divided by 2.
And then divide everything by 2, turn them into that. I'd be like, oh, I guess that angle was how big? How big was that angle the whole time? It was 60 degrees, but we're working in radians, so I'm going to say 5 and 3.
Wait.
However, you guys said it was okay.
That makes sense.
Really, though, here's what most people are going to do here. You got to go. Good luck in your game. What's the tangent of pi over 4?
1.
Okay. So if someone's talking about an angle whose tangent is like root 3 over 3 or root 3, it's obviously not this guy, right?
Mhm.
So it really narrows it down, narrows down your search to like what triangle you're searching for, right?
Yeah.
So then a lot of people will just be like, well, there's really just 2 tangents to know, right? Well, actually, it's really just 1. The tangent of pi over 6 is root 3 over 3. We've done that result before. And the tangent of pi over 3 is root 3. So if you have those like semi-memorized, then you can reason this one out. That it's got to be pi over 3. Any further? I don't mind just to keep going. I mean, I don't want you to. I want you to do a few on your own because otherwise you might just never figure it out.
No, I got it figured out.
We can do one more, like I wanted to do H. Yes. What? The brain's bonking.
Yeah.
The bonk.
Well.
James, you know about the bonk?
Totally.
Do you guys talk about the in running? Do you guys talk about the bonking?
No.
It's where you like completely. Well, they say it's like when you've completely hit a wall and you just like physically cannot drive your body forward anymore. It's the bonk. I wasn't sure if you guys talked about that. They say sometimes people do like a marathon, they'll like just hit a point. You ever see someone in like those videos? They'll basically just like collapse. Just no more energy. No more energies. Okay, you're done. Inverse cosine of negative root 3 over 2. Look at that. Now, yeah. So here, where's my triangle? Did I step on him? No. Okay. Here he is. How can I make him? Well, okay, I got ahead of myself. I'm sorry. Is it obvious why it's not the 45, 45, 90 though?
Yeah.
Right.
Yeah.
That guy would be like, if you had a root 2 over 2, then you'd know, that's the guy I'm dealing with, root 2 over 2 guy. But he's the root 3 over 2 guy, so you know it's this man. And that's his long side, right? How can I position him on the circle so that his, now, do I want his x value to be this or his y value to be that? I want his x value to be that. So where does he live?
On the circle.
He lives over on the left side. He lives over here in the second quadrant.
Oh.
Does that make sense? No? Okay, he can't live here. Why? Because if you live here, what kind of x value do you have?
Positive.
You have a positive x value.
Right.
If you have a positive x value, you have a positive cosine.
Yeah. Yes.
So he has to live over here. And then I take my triangle, and And I need him to be like this. Is that visible enough?
Yeah.
So I need to go whoop, and I need to land here. Now this little dude right here, that little angle I drew, how big is he? 30 degrees. Or 1/6 of pi. But ultimately the angle that I'm talking about is in reference to this starting point. So how far over did I really go? 5/6 of pi is how far I went. So the answer is 5 pi over 6.
Yep.
Feelies?
Check.
Feely's bad.
Bad?
Yeah.
Why bad?
Brain goes bomb.
Brain go.
Just here, try, then, I've been there many times myself. You go home, you review it for